sir.
Yeah, tell me, madam. Tell me. Hello.
Yeah, Mahadev sir. Participants, is he audible? I think there is a little bit of clarity problem in the mic. Others, can somebody tell us whether you are able to hear him?
Hello.
Yeah, tell me, sir.
Yeah, it is audible, sir. Just little bit of sound, uh, just you can check clarity. Audible, sir. Audible. There's not a
Audible,
problem.
sir. Because I'm having one more device with me now, sir, actually. So here also it is, I think, audible now for me now. Mm, Full screen, if you want, I will make, sir. 1 minute. Or else I will share my screen itself. Just check it, sir, whether this PPT is visible or not once. Hello, can you hear me?
Yes, sir. Visible, sir. PPT also visible, sir. And sound is also audible.
Okay, fine, sir. Continue. So ambient system everywhere, if you consider from anti-lock brakes or as autofocus cameras or automatic teller machines like that, we are having so many examples, moderns if you consider, network cards if you consider, scanners, pagers, what we previously used to make of it. Then smart oven, dishwashers if you consider, speech recognizers if you consider, almost these all things are made up with what embedded system. So you will be having embedded system everywhere. Now we come to definition of embedded system, or is what embedded system may have, or is it must include, or is it should have like that. So embedded system is what is a combination of the three things. So first it should have hardware, then software, along with that mechanical components for what applications you are planning it for, so for what purpose you are making that whatever embedded system you are having. So like previously in this slide, whatever we are seeing it, so many applications you are seeing it. So for those things we used to have what mechanical components involved with that, along with the hardware software, and it is supposed to do work on a specific task only. So like for example, if I take a washing machine, so washing machine from an embedded system, if we consider a embedded point of view, should have hardware like buttons, display, buzzer, electronic circuitry, or else if today's few on advanced things if we consider Bluetooth like that. So we can connect automatically to with the help of Bluetooth. Then software, if we consider, it has a chip on a circuit and that holds software, which drives, control, and monitors the various operations which are possible. So mechanical components what they used to make out the internal of whatever the things which has to be washed, which has to be dried like that. There are so many internal washing machine things they used to make out actually wash the clothes, control input output like that. They used to handle those kinds of things that we used to come here in this mechanical component. Then, how many do we use? As I told, so average middle class home has around, as I told, 40 to 50 embedded processors in it. So, as you might be knowing it, microwave to washers, dryers, dishwashers, if you consider TV, VCR, stereo, hair dryer, if you consider coffee maker, remote control, humidifier, heater, toys, etc., etc. Not, I think, more than this at present. What processors we are talking in, more than 40, 50 at present, if you consider middle class. And similarly, if you consider one luxurious car, so that is will be having around 80 embedded processors from brake towards steering, windows, locks, and ignitions, dashboard, display, transmission mirrors. Everywhere we are having more processors. So luxury cars they are having around 80 embedded processors in them. Then personal computers, if you consider, personal computers, they are having around 10 embedded processors. They are nothing but graphic accelerators, if you consider mouse, keyboard, hard drive, CD-ROM, then bus interface, the network card, like that. There are so many, whatever we used to make out with also vehicles that used to that is to be considered with the personal computer. So they used to make almost more than 10 embedded processors. So like this. So if I just go for one more example, air conditioner like that. So again, it used to have a hardware, software, mechanical components like a remote display, buzzer, infrared sensors, and electronic circuitries like that. In software, again, they used to what they used to control drivers and monitor the various operations which are possible. That is to be made in software part. And coming towards the mechanical components, the internals of an air conditioner, if you consider the motors, chassis, and outlets, they used to make mechanical components. So that motor should rotate, chassis should play where you are planning to make out with. So like that, almost those things has what mechanical components has to be played very important. So an embedded system is what now? That is nothing but what designed to do a specific job. As we have seen, washing machine can only wash clothes, and air conditioner, if you consider, can control the temperature in the room in which you are planning to be, or else where that is placed. And hardware mechanical components, if you consider, will consist of what? Will consist of visible things. So that are what that are used for input, output, etc. So embedded system will always have a chip with as we know, microcontroller, processors like that will come to know later. That has what? That has a code or a software which drives the system. So here is one more example. So that is nothing but an embedded system example for a digital camera, if you consider. So digital camera, if I consider, so what all you will be having? You will be having CPU, central processing unit, along with whatever the processing they used to make out with the flash adapter or memory control. If you consider, you will be having flash, DRAM, memory card. So these all things will come to later. So what actually microcontroller that used to make out, what microprocessor that used to make out, what is the difference between these two? So that we'll study in later sessions. So if we just have an overlook of this, so there will be what there will be a CPU like that. So CPU will be what that used to make out memory control. So memory will be what memory is attached with the flash, DRAM, memory card like that. Used to fetch information or whatever the memory card control that used to make out. Then along what major things actually memory CPU that used to make memory control. Then a JPEG coprocessor, whatever they used to make out with the camera DSP. So coprocessor that used to just catch and that used to make out with us that used to interconnect with the central processing unit. Similarly, we'll be having Ethernet interface like Ethernet. If you consider there are so many more connectivities like that. So Ethernet interface that can be controlled with the CPU. Then IO control. So IO control RS2 like interface what you are planning to make out with the RS232 interface if you are planning as LED Bluetooth model. So like that. So you just make out with the IO control and the IO control that used to make that used to connect with the CPU. Here, if you just consider embedded system, you will be having analog, digital part. Then finally, the analog part will be dispersed like that. So the major application is what to get information and store it, or else for application purpose you are planning to proceed with. So to get that, you will be having what you will be having a lens, then DSP or else camera that is nothing but analog to digital converter that used to make out, and a DSP that used to proceed with memory or else that used to store there like that. If you consider at present overview of this digital camera. So similarly, if you just consider for others, like this here, we are having a processor, coprocessor, memory, controller, interface, converter, ASIC. So like that, there are so many things involved here with an embedded system example. If you consider. Come towards history of embedded system. If you just come across history of embedded system, how they developed, or how they just made, or else they came at present what you are having. At present, we are having more advanced feature than this. Not only we are not in a second, third, fourth, fifth generation. So almost the technology is changing day by day, and those concepts, if I just go back with the history, so we are having few concepts, or else embedded system they used to make out a few things here. So So here are important milestones from history of embedded system if we consider. If I go back to the 1960, embedded system was first used for developing Apollo guidance system by Charles Draper at MIT, that's nothing but Massachusetts Institute of Technology. Then in 1965, we consider aeronautics developed the D-17B, like there is nothing but computer used in a Minuteman missile guidance system. So again, for application purpose, 68, if we consider 1968, the first embedded system for a vehicle was released. Then Texas Instruments, if we consider, developed the first microcontroller in 1971. Then later, 1987, first embedded operating system that used to work with VX Works was released by Wind River. Then Microsoft's Windows embedded CE came in the year 1996, and if you go back to the late 90s, the first embedded Linux system appeared. So and then the market, whatever that is there after 1990, almost that used to reach with present if you consider they have given 2013 140 billion like that, but as I know to 2025 if we consider, so almost if we just make out with only market, almost with the market it used to make out with 120 billions 2025 if we consider. So that is a market of embedded system. So like at present, if you consider any application, you will be having controllers, so processors related to that application, and they used to make out. Today, if we just consider one processor as a controller, as one application-based controller, so tomorrow alternative to that. So if that is operating with the help of Bluetooth, so tomorrow with some more advanced. So we can just make out with some other advanced features like that. So almost embedded market if we consider the thing that is larger, and even that is making out if we just consider billion wise 140 billion or is 130 billion or is 180 billion 400 billion, like almost the market is getting widened. So that's the history of embedded system, how they just came up with, and today where we are standing. Then design parameters of embedded system if we consider. So what are design parameters? How they used to make out, or which all parameters they used to consider for design parameters for these whatever embedded systems we are making it for. They used to consider obvious design goal like construct an implementation with the desired functionality. Then key design challenge. There is in this key design challenge, simultaneously optimize numerous design matrix. So obvious design code, construct an implementation with the desired, okay, a desired functionality you want to make out with. Then key design challenge, what that used to make out, simultaneously optimize numerous design matrix. Okay, we can just alter this towards any some key designs we can just make out for whatever construction that we gave, no, for that, like that key design challenges, whether they can meet, we need to consider. So then design matrix, if we consider, there's nothing but a measurable feature of a system's implementation. So where they used to make out what the features you are having. Then optimizing a design parametrics, if we consider optimizing design matrix is a very important role, because how much you optimize, not only the size or the wise, or is not only amount dollars the cost wise, not only the power consumption wise. So we need to consider so many parameters actually. So if that design, whatever you are making it, so that has to reach within a specified period of time, within a short span of time, and before reaching the advertisements or else whatever we used to make out with, okay, this has the what, this is wonderful device, and whatever the challenges you are having, you are facing. So like that, if we need to consider, if we consider parameters, so we need to optimize design metrics in what that is nothing but a key challenge we used to qualitize. So we are having few more things here, one by one. So common matrix, if we consider, we used to consider with the unit cost. Unit cost is what the monetary cost of manufacturing each copy of a system, if you consider excluding NRE cost. So what happens here? NRE cost. non-recurring engineering cost, we used to call it as. There is nothing but the one-time monetary cost of designing system. So we need to include actually. So NRE cost should be divided with how many devices you are making it. Then size, the physical space required by the system, and the performance wise, the execution time or the throughput of a system if you consider. Then power wise, the amount of power consumed by the system. Flexibility, as I told, the ability to change the functionality of a system without incurring heavy NRE cost. So if we are having key design challenges, or as we can make a numerous design matrix, almost this flexibility part we can overcome them. Then time to prototype, the time needed to build a working version of system. So that again makes somewhat importance with this common matrix. Then time to market, the time required to develop a system to point that it can be released and sold to customers. That is very important, time to market. Then maintainability, the ability to modify the system after its initial release. So we need to what? We need to upgrade, or else we need to enhance it, as I told. So today, if you are planning to make out with what this mobile is with what this mobile is operating with the Bluetooth. So tomorrow we can just make out. We can enhance few more characters so that can attach with TV with some cable. So that's nothing but the ability to modify the system after its initial release. Then correctness, safety, many more if you consider battery or some power consumption wise if you consider. We need to have a safety for those things. So correction, safety, many more things they used to make out this common matrix. So that's what they just shown here. NRE cost wise, performance wise, power wise, size wise, we need to consider. Then expertise with the both software and hardware is needed to optimize the design matrix if you consider. Not just a hardware or software expert. As in common, a designer must be comfortable with the various technologies in order to choose the best for a given application and constraints. So if we just pass with these things, various technology in order to what, in order to choose best for a given applications, then I think that model, or else whatever that unique application based system is there, embedded system is there, that will play a very important role. Here we are having time to market a demanding design matrix. Just a minute, just a minute. They are having AICT's official inauguration. So at present, we'll just leave. All of you, please join inaugural session of AICT, whatever link they send. So after that, I will continue.
Dr. Mahantesh,
Yes, sir. Tell me, sir.
you will have to stop here and with the kind information to all the participants that they need to join, they need to log in to the link that we have provided in the group, because AICTE is conducting the inauguration of 28 ATAL FDPs that have started today. AICTE is conducting the inauguration of 28 ATAL FDPs that have started today. All the participants are expected to join by using that link. Kindly use that link and see that program. Thank you.
Please join in.